All right, we've got a breaking news edition of WNY Over the Air. Apple has apparently filed a patent adding ATSC or 5G broadcast capabilities. If you're confused as to why Apple would do something like this, I mean, you're thinking TV antenna, doesn't that sound old? Let me break it down for you. But first, if you're new to the channel and you're interested in all of this broadcast stuff, subscribe. I literally talk about the future of broadcast technologies, which are actually really advanced and really cool. They can do so much more than you probably think they can do. That's why I'm very proud to have this YouTube channel where I'm going into all of this future broadcast technology stuff. So if you're interested, definitely stick around and subscribe. Without further ado, let's get into this patent. So why would Apple want to do this in the first place? So in my opinion, Apple is doing this for a couple of reasons. There are some really incredible modern broadcast technologies that are extremely efficient at sending data. So if you don't know the unicast versus broadcast model, the current way that all content, all live streaming content is done over the internet is done via unicast, which means, let's say there's 10 million people watching an NFL game. All 10 million people are receiving 10 million individual copies. So if it's taking up 6 megabits per second, that would be 60 million megabits per second of data that would have to be sent across a network. And that is extremely inefficient at sending something that a lot of people are all watching at once. Whereas with broadcast, that 6 megabits per second could be sent to 10 million people and it would only have to be sent once. So you're essentially shrinking 60 million megabits per second to literally just 6 megabits per second. Very modern, very robust broadcast technologies can be implemented to be received flawlessly with extremely poor RF environments, to the point where you could literally be 75 miles away from a transmitter underground in a basement or in a parking garage and you'd still be able to receive it perfectly fine. And also, I just think that this would be a really cool add-on to have when you're offline, when you don't have an internet connection. Right now, Apple has the functionality for you to send information to 911 or text a friend using a very low capacity satellite communication method. This would add to that as a second capacity for somebody to still receive data when they don't have an internet connection. Just think, cell sites cover maybe 3 to 4 miles at the most if it's low band 5G, whereas a broadcast signal can stretch literally dozens and dozens and dozens of miles. So a broadcast signal could theoretically reach, with ATSC 3.0, if the signal was sent with the most robust implementation, you could theoretically have a 150-mile range. Broadcast inherently travels to places where cellular services do not travel to. And this means if you're in the middle of nowhere where T-Mobile, AT&T, Verizon, and Dish aren't going to be putting up cell sites for, well then the broadcast signal, the broadcaster didn't have to specifically add capacity in that area. Their broadcast capacity is just flowing there anyway, just because it's a byproduct of having broadcast. It's just flowing in that region, even though it's not targeted necessarily for that region. Now, I had made a video, believe it or not, about 10 months ago where I was discussing if Apple has anything to do with ESPN in the future. I think they should use ATSC 3.0 and 5G broadcast to send ESPN over the air. And the reason why I said that is for all the reasons that I've kind of outlined already, which is it is way more efficient to do it that way than to do it via unicast. But anyway, that's enough context. Let's get into this patent. This is a patent filed in the United States Patent Office. You can see I have it up here. This is from the official .gov website. This is absolutely incredible. Again, this was just published the 26th, so literally yesterday. And this was filed February 29th. So they submitted this February 29th, and then it just got officially released to the public yesterday. But as you can see, it shows this Apple Pencil looking device receiving signals from two broadcast transmitters here and then it shows some sort of external device with a screen that has this Apple Pencil device wirelessly sending the broadcast signals from the accessory to this other device. As you can see here, it says radio frequency front end, and then it says ATSC demodulator and partial 5G broadcast demodulator. Now, it doesn't say ATSC 3.0, it says ATSC. When they are referring to ATSC, they are 100% referring to ATSC 3.0. They would never implement ATSC 1.0. First off, the waveform is trash. It's technology from the 90s that actually was first developed in the late 80s and in the 90s. The data capacity is trash. And then multipath is a nightmare. There's no way that they would be adding an ATSC 1.0 demodulator in this. They are referring to ATSC generically, but I can almost guarantee that they are referring to ATSC 3.0 in this case. And then they go into the design of the accessory. Now, they don't specifically say Apple Pencil, they're just saying some sort of accessory. So literally what this is some sort of accessory that has a built-in antenna into it and has a built-in either ATSC 3.0, I'm assuming, demodulator chip and or a 5G broadcast demodulator chip. The actual accessory is doing all of the, tuning the waveform, demodulating it, and extracting the binary code, and then sending it via Bluetooth to, in what they're showing, an iPad. And it goes on more. You can see the antenna layout. They go into how they would put the antennas in here. They go into the whole process of starting from the RF front end all the way to decoding the audio and video streams. This is a really cool diagram. This reminds me of what Apple has just started getting into. Apple just a couple years ago started getting into satellite communication, specifically being able to call 911, text 911, and then now more recently being able to text message or iMessage using a satellite in space. So what's really cool about this is this diagram where it says broadcast signal strength, rotate device. It reminds me of the same situation that they're currently implementing with satellite communications. And they go into why you would want to have something like this in the first place. I'm going to bring up an article from Apple Insider. It says here, Apple's reasoning for an Apple Pencil TV antenna. Apple says, quote, electronic devices have also become ubiquitous for consumption of audio, video, and other media in a convenient manner. These functions may also be unavailable when cellular or other internet-connected networks are unavailable. Moreover, due to the ubiquity of internet-based on-demand content delivery sources, for example, streaming video, as well as the general trend towards smaller and lighter electronic devices, such devices may not be configured to receive and or process broadcast content, such as broadcast TV signals. Now it goes on to say, accessories that are configured to receive and process broadcast signals and wirelessly communicate the content from the broadcast signals to the remote electronic device. So one aerial receives the signal, which could be an advanced television systems committee broadcast protocol, and then a second transmit to the iPad or other device. And it goes on to say it could also use a, quote, fifth generation 5G broadcast protocol. So first off, I just think that this shows that Apple is interested in broadcast. Just because Apple filed this patent doesn't mean that they'll ever use it, but there is a chance that they could use it in the future. This patent will expire in 20 years. So essentially, in the next 20 years, something like this could happen. Now, I want to go back to a patent that was filed in 2010, where Apple filed a patent about adding HD radio into an iPod or an iPhone. And back then, they were interested in adding HD radio to the iPhone in order to do the iTunes matching, so that when you were listening, it would come up with a little iTunes tagging feature, which is one of the baked-in features of iBuity's HD radio technology. So this was a way for them to kind of integrate broadcast, and it'd be a super convenient button where you could just tap on it and it would send you to the iTunes store, where you could then make a purchase. Well, what has happened since then? Apple Music and streaming services. So obviously this didn't really pan out. And obviously HD radio as a technology, in my opinion, sucks. And I've gone into that in a different video. The waveform compared to what could be done with 5G broadcast or ATSC 3.0 is way worse. And it's not internet protocol based. It's not flexible. So anyway, I think this is really, really cool. So I'm going to leave it there. This was just a little bit of breaking news that I wanted to get out. But anyway, thank you guys so much for watching, and I'll see you in the next video.